Example 15. A pole with 6 meter tall is adjusted away from a street light. As we see in the diagram, we are able to look at this part where this is the 6 meter tall pole is adjusted away from the street light, which is 20 meter high at the rate of 7 meter per second. At what rate is the length of the pole's shadow increasing? Here we can let x to be the length of the pole's shadow, where it is shown in the diagram here, and the shadow of the 20 meter high street light is as s plus x. Let us start with the step 1 to identify changing variables, constant variable, and a rate of change to be found for this question. As we observed, the changing variable which is given in a derivative form for this question is the s variable, where we have ds over dt to be given as 7 meter per second. Next is constant variable. In this question, we have two constants. One is height of the pole, which is 6 meter, and next is height of the street light, which is 20 meter. And finally, the rate mentioned to be found was very clear, that we need to find dx over dt. In step 2, we need to state the equations involved and form chain rule. For that, we will be referring to this triangle provided and able to extract two similar triangles as here. Using concept or idea of comparing the ratios of the sides, we will have 6 over 20 as equals to x over s plus x. Simplify this, we will have 6s plus 6x equals to 20x. This will give us 14x equals to 6s. And to write x as the subject, we can have 6x over 14. And x can be simplified as 3 over 7s. The next thing to be formed is a chain rule. Again, referring back to the question, the derivative that we need to find or to be found in this question is dx over dt. In the process of finding this and found x as the subject, therefore we can relate this using the formula of dx over ds. We need to multiply this with another derivative in order to cancel off this ds and create dt. As we known earlier, the question has been provided us with ds over dt. Therefore, this is the chain rule and the equation to be used in this question. Step 3 is to differentiate the equations by referring to chain rule formed. Based on the chain rule formed, we have dx over dt to be dx over ds multiplied with ds over dt. As we know, this is given in the question, and this is to be found from the process of differentiation. In step 2, we have already obtained equation relating x and s, where x equivalent to 3 over 7s. This is quite a simple equation, where to find derivative x with respect to s, we need to have dx over ds as 3/7. Well, now we are in step 4 to evaluate answer for this question. We have found that dx/ds for this question is 3/7, and the chain rule formed here is dx/dt as dx/ds multiplied by ds/dt. Using these two informations, we can plug in a 3/7 as well as the value of ds dt provided in the question to calculate dx/dt. Therefore, we will have dx/dt as dx/ds 3/7 multiplied with the value of ds dt, which given in the question as 7. Simplifying this, we will have dx/dt as equals to 3 meter per second. Finally, we are in step 5 to solve this question. As we obtain a dx/dt to be equivalent to positive 3 meter per second, we need to explain the meaning of this rate. For that, we can refer back to the sentences in the question, which tells us the definition of x. X is the length of the pole's shadow. Therefore, we can write here length of the pole's shadow is increasing by 3 meter per second.